Have you ever seen electricity being produced without a battery? This magical phenomenon you're seeing is called electromagnetic induction. So what exactly is it? Simply put, electromagnetic induction is the process where an electric current is produced inside a conductor whenever the magnetic field around it changes. For your exams, remember this key line: when the magnetic flux linked with a conductor changes, an induced current flows in it. It's a fundamental concept in physics, and it was discovered by the brilliant scientist Michael Faraday way back in 1831. That's a classic one-mark question, so don't forget his name. Let's break it down with a simple experiment. Imagine a coil of wire connected to a galvanometer, which is just a device to detect small currents. When we move the north pole of a magnet towards the coil, look, the galvanometer needle deflects, showing a current is flowing. Now, if we pull the magnet away, the needle deflects again, but this time in the opposite direction. But what happens if we just hold the magnet still, either outside or inside the coil? Absolutely nothing. The galvanometer shows zero. The key takeaway here is that current is induced only when there's relative motion, meaning the magnetic field is changing. A stationary magnet creates no current, so how can we make this induced current stronger? There are three main ways. First, move the magnet faster. The quicker you change the magnetic field, the larger the current. Second, use a stronger magnet. A more powerful magnetic field will induce a greater current. And third, increase the number of turns in the coil. More loops mean the wire cuts through more magnetic field lines, boosting the current. This is a super common 2 or 3 mark question in exams, so make sure you know these factors well. Now, how do we know which way the current will flow? For that, we use Fleming's right hand rule. It's pretty simple. Stretch out your thumb, forefinger, and middle finger of your right hand so they are all perpendicular to each other. Your thumb points in the direction of the motion of the conductor. Your forefinger points in the direction of the magnetic field from north to south, and your middle finger will then show you the direction of the induced current. A cool memory trick is to think of FBI: F for field, B for brain or motion, and I for induced current. This isn't just some abstract physics concept. It's all around us. Electromagnetic induction is the principle behind electric generators that power our homes. It's used in transformers to change voltage levels, and you can even find it in bicycle dynamos that power the lights on a bike as you pedal. In fact, our entire power grid, from power stations to our outlets, relies heavily on this principle. Let's try a typical exam question. What happens when a magnet is held stationary inside a coil? The answer is no current is induced. Why? Because there is no change in the magnetic field linked with the coil. Remember, no change, no current. So for a quick revision, electromagnetic induction was discovered by Faraday. It requires a changing magnetic field to produce a current. We find the direction of this current using Fleming's right hand rule, and it's the core principle behind generators and transformers. If you truly understand electromagnetic induction, topics like electric generators will become super easy for you. Thanks for watching. If this helped clear things up, give this video a like and subscribe for more physics lessons made simple. See you in the next one.